The five numbers 1 over 4, 4 over 10, 41 over 100, 0.04, 0.404 are to be listed from smallest to largest. Which number will be in the middle? Let's convert these to decimals first. That'll be 0.25, that'll be 0.4, that will be 0.41, and the rest are already converted, these guys. So let's now list them from smallest to largest. So the smallest, I believe, is 0.04, then 0.25, then 0.4, 0.404, and finally 0.41. And the middle one is this one right here. So in their original list, that was this guy, 4 over 10, is the middle of the list. In the diagram, two 8 by 10 rectangles overlap to form a 4 by 4 square. What is the total area of the shaded region? Total area of the shaded region will be the rectangles areas. So each one is 8 by 10. So you have to multiply by 2 since there's 2. But you have to subtract that white box in the middle. That white box has dimensions 4 by 4. But it needs to be included twice because it will be part of each of the two rectangles. So you put a 2 out front. And that's the math. So this will be 160 minus 32. And that is 128. A dish contains 100 candies. Juan removes candies from the dish each day, and no candies are added to the dish. On day 1, Juan removes 1 candy. On day 2, Juan removes 2 candies. On each day that follows, Juan removes 1 more candy than he removed on the previous day. After day n, Juan has removed a total of at least 64 candies. What is the smallest possible value of n? So let's make a little chart. There's a few ways of doing this question, but I'll just do it the extensive way just to make you understand. And we have a chart that consists of the day, how many we had at the start, how many we have remaining, and how many have we removed in total. So cumulative removed. So for example, on day well, let's put 1 here. On day 1, we started with 100, and we're going to remove 1. So we removed 1 in total. On day 2, we actually started with 99, and we're going to remove 2 this time, so we're going to end up with 97. And cumulatively, we removed 1 and then 2, so we removed a total of 3. On day 3, we start with 97. This time, we have to remove 3. So this will go down to 94, and our cumulative is 1 plus 2 plus 3, which is 6. And they just keep going like this. So 94, 90, 10, and then we want this to be at least 64. Removed a total of at least 64 candies. So we have to see when this number in this column gets to at least 64. So let's see what happens. And then we're going to have to look at what day it was, because that's what they're asking. So 85, this will be 15, 6, 85, 79. This time we removed 6, so that's 21, 7, 79, 72, 28. And let's see here, 8, 72, 64, 36, 9, 64, 55, 45, 10, 55, 45, and 55. Okay, we're almost there. And 11 is 45, 34, and 66. So we got to at least 64, and that happened on day number 11, and that would be our n. In the diagram, 9 identical isosceles trapezoids are connected to form a closed ring. What is the measure of angle ABC? So what I'm going to do is draw a dot in the center and then connect that dot to the, I guess, the trapezoids like that. And then that will allow me to figure out the angle right there. Now, the whole angle all the way around is 360, right? And how many of these triangles did I create? 1, 2, 3, 4, 5, 6, 7, 8, 9, 9. So 360 divided by 9 is the individual angle. Now let me draw that shape here. This one of those triangles. Be a little bit easier to explain. So this is A, this is B, and this is C, right? And the angle here is 40. And then since this diagram is symmetric, that triangle is isosceles. Those two sides are the same. So therefore this angle and this angle, if we call them x, we can calculate. It would be 40 plus 2x is 180. So that means x would be 70. And angle ABC is this guy, and that's just going to be 180 minus 70. So that would be 110. So angle ABC is equal to 110 degrees. Determine all pairs xy of integers with x less than or equal to y, for which 1 over x plus 1 over y is equal to 1 over 4. Okay, so if x is less than or equal to y, that means 1 over x is greater than or equal to 1 over y, or we can write 1 over y is less than or equal to 1 over x. Same thing. All right, so then where do we go from here? We have to get some sort of boundaries. So let's see here. If 1 over 4 is equal to 1 over x plus 1 over y, then that, if we look at this and this, that means that will be less than or equal to 1 over x plus 1 over x. And therefore 1 over 4 is less than or equal to 2 over x, and therefore x is less than or equal to 8, I believe. Yeah. So that's one boundary. And then we want to get the boundary on the other side, what it's greater than. Now, we are not told if x and y are both positive or not. There could be a negative in there. But for this case, let me just assume that both x and y are positive. If so, 1 over x plus 1 over y, since it equals 1 over 4, that basically means that 1 over x has got to be less than 1 over 4. And therefore, x would be greater than 4. Yeah. So there we go. When we combine these two, we would get that x is between 4 and 8. So that means x is either 5, 6, 7, or 8. Because it's less than or equal to 8, but only greater than 4. Okay, so that's actually not so bad. We just have to test out those 4. Okay, so let's start with x equals 5. And of course, we're going to use this standard equation. If 1 over 5 plus 1 over y is equal to 1 over 4, when we solve for this, you will get y equal to 20. And when x equals 6 and you solve for the same thing, you will get y equal to 12. When x equals 7, you will get y equals to 28 over 3. Now that's not an integer, so that is not solution. When x equals 8, you will get y equal to 8. So our only integer solutions are 5, 20, 6, 12, and 8, 8. All right, so that takes care of those guys. Now, remember, the question didn't tell us that they both have to be positive, x and y, so there's going to be some negative. Now, one thing we know is that x is less than or equal to y. Now, they both can't be negative because they add up to a quarter, but x could be negative, and that means y is positive because x is less than y. So since 1 over x plus 1 over y is equal to 1 over 4, that means that 1 over y, I should say, is greater than 1 over 4, because you're going to subtract from it a negative. You're going to subtract from it a number and bring it down to 1 over 4. So that means that 4 is greater than y. So y is less than 4, so y is either 3, 2, or 1, since it's got to be an integer. And we have called it a positive integer. Okay, so let's now look at those guys. If y is 1, again, using that standard formula, this guy, when we solve for that, when we solve for x, we will get x equal to minus 4 over 3. That's not an integer, so that's no good. When y is 2, we will get x equal to negative 4. And when y is 3, we will get x equal to negative 12. So that gives us two more, minus 4 and 2, and minus 12 and 3. So these guys are the solutions to that original equation. There are 90 players in a league. Each of the 90 players plays exactly one match against each of the other 89 players. Each match ends with a win for one player and a loss for the other player, or with a tie for both players. Each player earns 1 point for a win, 0 points for a loss, and 0.5 points for a tie. After all the matches have been played, the points earned by each player are added up. What is the greatest possible number of players whose total score can be at least 54 points. So we have 90 players, and you get 1 point for a win, and 0.5 points for a tie, and 0 points if you have a loss. And then each player plays the others, so 90 times 89 is the total number of games, but we have to divide by 2 because otherwise we double count. So there's 4005 total games played. Now each game results in 1 point. If it's a win-loss, it would be 1 plus 0. If it's tie, it would be 0.5 plus 0.5. Each player would get 0.5. So each game has a total of 1 point being awarded. Either a win-loss situation, which would be 1 and 0, or a tie-tie situation, which would be 0.5 and 0.5. Okay, so that means for 4005 games, there would be 4005 points. Okay, so now let's talk about what the question is asking. That was just the setup, this part. The question is saying we want to figure out the number of players who can have a total score of 54 points, each of them. So let's say that number is n. If each of them has 54 points, that means the total score would be n times 54 of all those players. Now the grand total is 4005, so that number has to be less than or equal to 4005 in order for this to work. So if we do this, n would be less than or equal to 74.2, I think. So therefore, since n is an integer, it's got to be less than or equal to 74. Now that's helpful because it kind of gives us a starting point. And we want the greatest possible. So we will start with n and then go down and then see what number allows us to achieve this, which is having players whose total score can be at least 54 points. All right, so let's start with 74. N equals 74. If n equals 74, then this guy here would be 74 times 54, and that is 3996. Okay, so the remaining points for all the other players, would be the grand total, which is 4005 minus this 3996, and that is 9. So that means you want 9 points for the other players. Now, n is 74. The total number of players was 90. So 90 minus 74 was 16 players. Now, we have to see if we can give 16 players 9 points. 16 players, each of them plays the other player. So the total number of games would be 120. So the number of games matches the number of points, so that means there'd be 120 points. But we want 9 points, and we need to have 120 points, so that doesn't match. So 9 and 120, there's no match there. So hopefully that made sense. And just for the sake of time, I'll skip this because this doesn't work. And n equals 72 also doesn't work. But good news is when n equals 71, it works. And I'll show you how. So same thing that we did up here. It would be 71 times 54. And that's 3834. And then the remaining points, which is the grand total, which is 4005 minus this guy, 3834. And that is 171 points. Now those 171 points are for the other players. So there's 90 total minus these 71, so that's 19 players. And those 19 players will play the other 18, and that will create 171 games. And those 171 games will have 171 points. So there you go. This 171, that 171 matches. So 171 matches the 171, and therefore this is a valid solution, and it's the greatest solution, which is what they wanted.